This is RD Sharma solution class 12. Chapter 19 exercise is 19.30 Indefinite integrals. Now whenever we talk about this form of integral, indefinite integral, that is the integration of rational algebraic functions by using partial functions. Now what is this form? There is a function fx and divided by a function gx. These are two separate functions. And we are integrating it, indefinite integral. Now what is the degree? See, if you have x square as the numerator and x cube as the denominator, 2 is the degree of the above one and 3 is of the below one. Now this fx, if the degree of fx is less than the degree of gx, that is the power, the highest power you can say, then we call it as the proper rational function. What do we call it? Proper rational function. But if the case is reversed, the degree of fx, that is the numerator, is greater than the degree of denominator, then we call it as improper rational function, IRF. So if you just take an example, x by x square plus 1, fx is fx and gx is x square plus 1. Now this is an improper rational function or proper rational function. The degree is 1 of the numerator, 2 is of the denominator, 1 is less than 2, that is, it is a proper rational function. Now let's take an example, x cube by x square plus 1. Numerator, the degree, the highest power is 3 and then x square is 2. So it will be IRF. Now what kind of questions we are going to get? What kind of relationship we are going to get? If you have a linear function px plus q and in the denominator you have x minus a into x minus b. Now this two, x minus a and x minus b, are factors. So the numerator is linear equation, denominator is a quadratic equation. The power or the degree of the numerator is less than the degree of the denominator. Now if you have this x minus a, x minus b, sometime you will not have it. You have to form the factors. So whenever we write the answer, you have to convert this px plus q by x minus a into x minus b as like a divided by x minus a. Then you take a constant b, a and b are the constants, and then x minus b in the denominator. So two factors, two values or two terms. One with the denominator x minus a, one with the x minus b as the denominator. Now this a and b will be evaluated, then we will integrate these two terms separately. Now what is the second form? Px plus q divided by x minus a whole square. So px plus q, which is a linear equation, we have x minus a whole square, which is again a quadratic equation, and this is a proper rational function. We don't use it or use the first kind of relationship. Here what we do is, again we have to have a and b, and you can have a plus because even if it is negative, b will come in negative. In the first part we have x minus a in the denominator, x minus b in the denominator, because x minus a and x minus b were multiplied in the denominator. Here you have x minus a into x minus a whole square. So a by x minus a and b by x minus a whole square. Now coming to the fourth one actually. I'll just talk about the third one. Fourth one is important because it is related to this one. If you have px square plus qx plus r, which is a quadratic equation, and the denominator has x minus a, x minus b, but x minus a has a square, then what do? The degree is 2 of the numerator, 3 of the denominator. It's a proper rational function. The first thing we'll write is a, and it is x minus a whole square. So you can call it as x minus a into x minus a into x minus b. So there are 3 separate things. But you'll not write like that, a by x minus a, b by x minus a, and b, c by x minus b. A, b, c, because there are 3 terms or 3 partial fraction kind of things. That's why we have 3 constants here. You can say that you have to use the highest order, and those number of constant has to be put in. Now x minus a whole square has to be written like this, x minus a here, x minus a whole square here. And what is remaining? X minus b. So now the third one, which is px square plus qx plus r, it is a quadratic equation which has the degree of 2, order 2. X minus a into x minus b into x minus c, these are 3 separate factors. In order to write it as a partial fraction, then because 3 terms are there in the denominator, you have a, b, c, 3 constants. Then you have x minus a, the first denominator term. The second one is x minus b, followed by third one, which is x minus c. Please remember p, q, r, a, b, c, small a, b, c is known to you. only capital A, capital B and capital C will be computed, and then we integrate them separately. So we are forming it in an easier way. The final one is px square plus qx plus r. That means numerator is quadratic equation. The denominator is x minus a, which is a singular term, or you can say linear equation. But here you have x square minus bx plus c, which is again a quadratic equation in the denominator. So in this case, when you have a quadratic equation in the denominator, what do you do? So it's a linear equation. So a by x minus a, x minus is a factor. It will come always a by x minus a. Now what to do with x square minus bx plus c? Here we use the differentiation concept. You are not able to divide x square minus bx plus c into two factors. It will remain like that. So x square minus bx plus c will come in the denominator, but the numerator will only have a linear equation. That is, in the first term, if you take the differentiation of d by dx, you'll get a constant term. So you'll get a 1. But when you differentiate x square minus bx plus c, what are you going to get? So d by dx of x square minus bx plus c is 2x minus b. This is a linear equation. So you write bx plus c. Then we have to integrate them separately as two terms. Now in order to understand all of these, let's take an example. Now 2x plus 1 divided by x plus 1 and x minus 2. So numerator is a linear equation. There are two terms or two factors in the denominator which are again in turn linear equations. If you multiply them, you will obviously get a quadratic equation. So this is a proper rational thing which we discussed. So proper rational function it is. So 2x plus 1 divided by x plus 1 into x minus 2 has to be converted or has to be written as a partial function so that we can integrate them separately. So we have two factors in the denominator, you can have two constant in the numerator. Now x plus 1 come first and followed by x minus 2 in the denominator. Now there are two ways, but first thing first is LCM. Sometimes if you find problem in finding the LCM, if it is p by q plus l by m, multiply p and m, so pm plus q and l, ql divided by q into m. So this is the simple way. So here, if you are not able to find out the LCM, then the best thing is that cross multiply first. A into x minus 2 is the first term. Then you add, because plus is there in between. Multiply b with x plus 1. This will be your numerator. The denominator will be x plus 1 into x minus 2. So you'll have x plus 1 into x minus 2 in the denominator. On the left hand side, it is 2x plus 1 divided by x plus 1 into x minus 2. Now you see the denominator are same, you can just cancel them out. Now there are two ways which I am going to suggest. One will be quite easy that you are going to follow later on, I am sure. But there is another way which I am going to show it to you now. 2x plus 1 will be equal to, just multiply this. A into x minus 2 will be ax minus 2a. What will be the second one? Bx plus b. Now just combine the x term or collect the x terms. So ax plus bx, that is a plus b into x. The second one will be b minus 2a. So 2x plus 1. Now equate. 2x is equal to a plus bx. So this will be your first equation because we are equating the similar terms. So a plus b will be equal to 2 will be your first equation. Second equation is b minus 2a, which is equal to 1. Now you have two equations, two constants, so you can easily find it out. Now just write this a plus b as b plus a equals to 2. Now subtract these. So b minus b here, minus 2a minus a minus 2. Now just cancel this out. Minus 2a minus a will be negative 3a, and 1 minus 2 is again negative 1. So negative cancels out. A will be equal to 1 by 3. So a equals to 1 by 3. Now put this in the first equation or the second equation. So you'll get what? 1 by 3, which is a, plus b equals to 2. Now b will be equal to 2 minus 1 by 3, which is 6 minus 1. Again, use this p by q plus l by m form. 6 minus 1 divided by 3. This will be 5 by 3. So a and b are known now. But this is the first way you have to do. If you are comfortable with this, go along. If you're not able to do like this, it's a better way. I'll show you a very nicer way. Now when you have 2x plus 1 equals to a into x minus 2 plus b into x plus 1. Now it's quite obvious that when you put x equals to 2, 2 minus 2 will be 0 and a terms, the first term with a will be eliminated. When you put x equals to negative 1, minus 1 plus 1 will be 0, 0 into b will be 0. So the second term, second part will be eliminated. So 2x plus 1 equals to ax minus 2 plus bx plus 1. One time we'll put x equals to 2, the other time we'll put x equals to negative 1. So x equals to 2 here, x equals to negative 1 here. This is the second and a nicer way, easier way I'm actually explaining you. So when you put x equals to 2, 2 minus 2 will be 0, a term will be eliminated, 2 into 2 because you have to put 2 here on the left hand side also. 2 into 2 plus 1 will be equal to b, 2 plus 1. So 4 plus 1 is 5, on the right it is 3, so I'm bringing it on the downstairs, b equals 5 by 3. In the left, which I showed you, you have to solve the linear equation. Here you don't have to. Now put x equals to negative 1. So the b term will be eliminated. Now put x at every place. So 2 into negative 1 plus 1 will be equal to a negative 1 minus 2. Minus 2 plus 1 equals to a into negative 3. So negative 3 into a equals negative 1, minus minus you can cancel, a will be equal to 1 by 3. Now whichever you want to use, you can use. Now this original equation, we have just done the half part right now. So we can write this 2x plus 1 divided by x plus 1 into x minus 2 because we are integrating it. So we have a, remember, it was 1 by 3, followed by 1 by x plus 1 you can write. So this is your first term. Then the second term we got b as 5 by 3. You can write 5 by 3 here, or you can write 5 by 3 into x minus 2. So this is your second term. Now we are integrating it, and you always know that constant can be taken out. So we are integrating 1 by x plus 1, we are integrating 1 by x minus 2. Now we are integrating it with respect to dx. Remember, dx is always there. I'm not writing it, but integration of 1 by x gives you log modulus of x. Modulus because we always have a positive value inside a log. Now 1 by 3 is there, 1 by x plus 1 is log x plus 1. Then we have 5 by 3, and this will be log x minus 2. Just write log modulus of x minus 2. We cannot have a negative value inside, or cannot afford to have, and plus a constant of integration. So this is how you're going to do it. Now let me give you a reference. This is a nicer way. You can just try it.